The most likely cause of flickering lights and erratic welder performance is a voltage drop in the electrical service. This can be due to several factors. Firstly, overloaded circuits where too many appliances or devices draw power from the same circuit can cause the voltage to drop. Secondly, undersized wiring, where the electrical wiring in the house is not large enough to handle the load, can also cause a voltage drop. Thirdly, old or damaged wiring can similarly lead to a voltage drop. In this particular case, it's likely that the electrical service to the house is inadequate for the welder's load. When the welder is activated, it draws a substantial amount of current, resulting in a voltage drop. This voltage drop affects the welder's performance, leading to erratic wire speed and poor weld quality. It also manifests as flickering lights in neighboring houses. The solution to this problem typically involves upgrading the electrical service to the house. This upgrade may encompass installing a new electrical panel, replacing existing wiring, or a combination of both. Upgrading ensures the electrical system can handle the demands of the welder and other appliances without causing voltage drops. Understanding voltage drop requires looking at a few key concepts. Voltage drop is the decrease of electrical potential along the path of a circuit. It is the loss of voltage caused by current flowing through the conductors of the circuit. Every wire has some amount of resistance to the flow of current. As the current flows through the wire, that resistance causes some of the electrical energy to be converted to heat. That conversion causes a drop in voltage. Voltage drop is important because electrical devices are designed to operate within a specific voltage range. If the voltage drops too low, the device may not operate correctly, or it may be damaged. The National Electrical Code, or NEC, recommends limiting voltage drop in branch circuits to 3% and total voltage drop, including feeders, to 5%. There are several factors that affect voltage drop. Firstly, the length of the wire. The longer the wire, the greater the voltage drop. This is because the current has to travel further through the resistance of the wire. Secondly, the gauge of the wire. Smaller gauge wires have higher resistance, leading to greater voltage drop. Larger gauge wires have lower resistance and less voltage drop. Thirdly, the amount of current. The more current flowing through the wire, the greater the voltage drop. This is because a higher current results in more energy being converted to heat. Fourthly, the type of wire. Different materials have different resistances. Copper has a lower resistance than aluminum, therefore copper wire will have less voltage drop than an aluminum wire of the same gauge and length carrying the same current. There are several steps that can be taken to reduce voltage drop. Firstly, use larger gauge wires. This reduces the resistance and therefore the voltage drop. Secondly, shorten the length of the wire. This also reduces the resistance and therefore the voltage drop. Thirdly, reduce the amount of current flowing through the wire. This can be achieved by using more efficient appliances or by distributing the load across multiple circuits. Fourthly, use copper wire instead of aluminum wire. To calculate voltage drop, you can use Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. The formula for voltage drop is volts drop equals current times resistance, or volts drop equals amps times ohms. For example, if you have a 100-foot length of 12-gauge copper wire carrying 20 amps, the resistance of the wire is approximately 0.198 ohms. The voltage drop would be 20 amps times 0.198 ohms, which equals 3.96 volts. This is a voltage drop of 3.96 volts divided by 120 volts, which equals 3.3%. To determine the appropriate wire size for a given application, you need to consider the length of the wire, the amount of current it will be carrying, and the allowable voltage drop. The NEC provides tables that can be used to determine the appropriate wire size. For example, NEC Table 310.15b16 lists the allowable ampacities of insulated conductors rated up to 600 volts based on their size, insulation type, and installation conditions. You can use this table to determine the minimum wire size required to carry a given current without exceeding the allowable voltage drop. In addition to these factors, it is also important to consider the ambient temperature and the number of conductors in a raceway or cable. Higher ambient temperatures and more conductors in a raceway or cable will reduce the ampacity of the conductors. It is also important to ensure that all electrical connections are clean and tight. Loose or corroded connections can increase resistance and voltage drop. Regularly inspect electrical systems for signs of damage or wear. Look for frayed wiring, cracked insulation, and loose connections. Address any issues promptly to prevent further degradation and potential hazards. Voltage drop can also affect the performance of motors. Motors require a certain voltage to start and run properly. If the voltage drops too low, the motor may not start, or it may run at a reduced speed and overheat. This can damage the motor and reduce its lifespan. In addition to the NEC recommendations, some local jurisdictions may have more stringent requirements for voltage drop. It is important to check with the local electrical inspector to ensure that your electrical system complies with all applicable codes and regulations. When upgrading an electrical service, it is important to hire a qualified electrician. A qualified electrician will be able to assess the electrical needs of the house, determine the appropriate size of the electrical service, and install the new electrical panel and wiring in accordance with all applicable codes and regulations. Upgrading an electrical service can be a significant investment, but it is an investment that can pay off in the long run. An upgraded electrical service will provide a safe and reliable source of power for all of the appliances and devices in the house. It will also increase the value of the house. In the scenario described, the fact that the lights are flickering in the neighbor's house is a strong indication that the electrical service is undersized. When the welder is turned on, it draws a large amount of current, which causes the voltage to drop not only in the house where the welder is being used, but also in the neighboring houses that are served by the same transformer. This is because the transformer is not able to supply enough current to meet the demands of all of the houses. Therefore, upgrading the electrical service is the most likely solution to this problem. While a licensed electrician is necessary for an electrical service upgrade, some smaller electrical work is suitable for someone who is knowledgeable and skilled in electrical work. This may include replacing a light fixture, installing a new outlet on an existing circuit, or replacing a circuit breaker. However, any work that involves the electrical panel or the main electrical service should always be performed by a licensed electrician. When working on electrical systems, it is crucial to follow all safety precautions. Firstly, always turn off the power to the circuit before working on it. This can be done by switching off the circuit breaker that controls the circuit. Secondly, use insulated tools. Insulated tools are designed to protect you from electric shock. Thirdly, never work on electrical systems in wet conditions. Water is a conductor of electricity, and working in wet conditions can increase the risk of electric shock. Fourthly, if you are not comfortable working on electrical systems, hire a qualified electrician. It is always better to be safe than sorry. When selecting an electrician, get recommendations from friends or family, check online reviews, and verify that the electrician is licensed and insured. A qualified electrician will be able to assess the electrical needs of your home, provide a detailed estimate for the work, and perform the work safely and in accordance with all applicable codes and regulations. In addition to upgrading the electrical service, there may be other steps that can be taken to reduce voltage drop. For example, using LED lighting instead of incandescent lighting can significantly reduce the amount of current that is drawn by the lighting circuits. LED lighting is much more energy efficient than incandescent lighting, and it can last much longer. Another step that can be taken to reduce voltage drop is to use power strips with surge protection. Surge protectors can protect electronic devices from voltage spikes, which can damage the devices. They can also help to reduce voltage drop by providing a more stable voltage supply. It is also important to properly size the extension cords that are used to power appliances and tools. Using an undersized extension cord can cause a significant voltage drop, which can damage the appliance or tool. The NEC provides tables that can be used to determine the appropriate size of extension cord for a given application. Understanding the principles of electricity and the factors that affect voltage drop can help in troubleshooting electrical problems and ensuring the safe and reliable operation of electrical systems. While some electrical work can be performed by homeowners, it is important to know the limits of your abilities and to always prioritize safety.